Welcome, Mr. Gazda here. Homework 35, Applied Physics. Okay, don't forget the goal here is for you to learn this. You should be maybe checking work that you did or have done something, tried it, maybe got stuck. You should not be sitting down with a blank sheet here and just watching this video. That would be the totally incorrect way of doing this. Trust me. So, I'm going to skip around a little bit. Look at this one here. It says, in a drill during basketball practice, a player runs the length of the 30-meter court and back. The player does this 3 times in 60 seconds. It has a little picture here. I'm going to jump to 2. The average speed of the player during the drill is... Okay, average speed. So, that's the average speed sign. What do we have? We have time. Time is 60 seconds. And what else do we have? We have the length of the court. So I guess we have the distance. But we have to figure that out because he runs the length of the court and back. So it's 30 meters and back. So every time he does it, it's 30 times 2. So it's 60 meters. And he does it 3 times. Times 3 times equals 180 meters. So the distance, the total distance that he ran is 180 meters. And let's look at the first one, average velocity, distance divided by time. So average velocity equals d divided by t. Therefore, the average velocity is what we're trying to find. The distance is 180 meters divided by 60 seconds. And here we go, 180 divided by, oh, I messed that up, 180 divided by 60 is 3. And the units are meters per second. Average velocity is 3 meters per second. There you go. Okay. 7. A truck initially traveling at a speed of 22 meters per second increases speed. Okay, so let's write stuff down. VI is 22 meters per second. Increases speed at a constant rate. What's that? That's our acceleration. 2.4 meters per second squared. Time for 3.2 seconds. That's time, 3.2 seconds. What is the total distance traveled by the truck during this time? Okay, so we're looking for D. D is our question mark. So with that, we have to kind of look here. V, I, A, and T. And D, we have this one here. D equals VIT. We have to use this one right here. Okay? So let's write this down. It is D equals VIT plus 1/2 AT squared. Therefore, D, what's VI is 22 meters per second times time, 3.2 seconds, plus 1/2, 2.4 meters per second squared times 3.2 seconds squared. Okay, so what are we going to have here? We got to look at the units here. The seconds and the seconds will cancel. So this is going to give me 22 times 3.2 equals 70.4, and the seconds cancel. It's going to be meters. So now D equals 70.4 meters plus. Here I'm going to have 3.2 squared. 3.2 times 3.2 equals 10.24. So plus 1/2, 2.4 meters per second squared times 10.24, and the units are seconds squared. Okay, so we're going to multiply this. Let's just do the units right here. Do the units. Notice second squared over second squared cancel. I'm left with meters, which is going to be good for this, and then the distance is going to be in meters as well. So then I just do the rest of the math. That times 2.4 times 0.5 for the 1/2 is 12.288. 12.288 meters, 70.4 meters plus that, and I'm just going to round that to, well, let's just do it, plus 70.4. It was let's round it to 82.7. Distance is 82.7 meters. Can you dig it? On the back, what do we got here? Now, please match up the last 2 digits of your locker number with the 2 letters that are next to it, and then write them on the front of your paper in a circle right next to your name. Thank you. Two, what is the final speed of an object that starts from rest? VI equals 0. Final speed is what we're looking for. VF equals, that's what we're looking for. Accelerates. Acceleration is 4 meters per second squared. Distance, 8 meters. Okay, what has those variables in it of our formulas? I'm looking for VF. Okay, this says VF, but it doesn't have time, but it has distance. So it's this one, VF squared equals VI squared plus 2AD. VF squared equals VI squared plus 2AD. Okay, so VF squared. Well, VI squared is 0, so that's kind of nice. 0 squared plus 2, 4. I'll write the units out sort of like this. Meters per second squared times distance, which is 8 meters. So let's focus on the units here. We'll go like this. Okay, so I'm going to get meters times meters and second squared times, so it's going to be meters squared over second squared. And then 2 times 4 times 8, which you should be able to, 2 times 4 times 8 is going to be 64. So now we have VF squared equals 64, and I said it was meters squared over second squared. Therefore, to get VF, you got to take the square root of both sides, including the units. Okay, so hopefully you can see that the square root of these units here is going to be meters over second, and that is 8. Therefore, VF equals 8 meters per second. Okay. Now I think what I need to do is I'll do one more. I'll do 4. We're at a point now, you should be able to do these on your own. For what is the time required for an object starting from rest to fall freely 500 meters near Earth's surface? So, object from rest, that means VI equals 0. Acceleration, you have to know that, and it is on the reference table. Know that acceleration due to gravity is a constant 9.81 meters per second squared. Okay, so you got to know that falling means that the acceleration is known, and it's that 9.81 meters per second squared. And the fall 500 meters, so distance is 500 meters, and we're looking for time. So with that said, what of these formulas can we use is going to work? We have VI, we have A, we have D. We're looking for T. I guess we could use this one. We could use this, right? We have distance. This has no distance. No distance, can't use that. This is, we don't have final velocity there, and that has no time in it. So we're going to use this. I'm going to write this down. D equals VIT plus 1/2 AT squared. So, when it comes to rest like that, VI, we have distance is 500 meters, this is what it falls. VI is 0, so 0 times T is going to be 0, plus 1/2 acceleration, 9.81 meters meters per second squared times t squared. Okay, so we have to solve for t squared. So what we do here is then you do 500 meters equals 1/2 of that, so that's 4.905 meters per second squared t times t. So I want to get sorry, t squared. I'm sorry, t squared. Right. Then I want to get t squared by itself. I divide this side by this. Cancels out. I do to one side, I do to the other. 4.905 meters per second squared. Now let's do the units here. Just 1 second. So I have meters divided by meters over second squared. So let's do our keep change flip thing. We'll do meters, and we keep that, and we change the sign, and then we flip it. Second squared over meters, meter over 1. Now what do we do here? We're going to glyph these, right? The meters cancel out. We're left with second squared. Okay, and then the number will be 500 divided by 4.905 is that. So I have 101.9 second squared equals t squared. So I want to get, alright, take the square root of both, get t by itself. Even the units, the square root of second squared is just going to be second. That's nice. Do the square root of that, and I get pretty much 10. Maybe 10.1. 10.1 seconds equals the time right there. Okay, so I think there's a few more. You need to do them, and we're totally at a point. You should be comfortable enough to do them. If not, go back, watch the other videos. But this is where we are, and this is where you need to be. Mr. Gazda, signing off.